Hi, everybody. How are you today? Thank you for joining us on Grade 10 Mathematical Literacy. I hope that we're going to have fun again today and that we're going to just carry on learning and getting better and more comfortable with the work we're doing. Let me quickly ask, how many of you that are here today wasn't here yesterday, didn't join us yesterday? Anybody? Is there anybody that's joining us today that wasn't here? Shanae, Cassie. Okay, so it seems like we've got some new students with us today. Oh, wow. Is it Kia? Or anybody else? So we've got 3 new students. Okay, thank you guys for joining us today. Last week and yesterday, we focused a lot on probability, and we're going to continue that today. I noticed yesterday that there are still some issues that we have with probability and doing the different tables and diagrams. But yesterday, we quickly went through everything that you guys did last week. So it was a lot of information. But then again, today, we're going to just go a little bit slower, stand still, look at only tree diagrams. So we're going to run through that again slowly but surely. I also gave you guys a problem yesterday, but we'll get to that. But yes, for those of you that don't know me, my name is Mike, Teacher Mike. You can just say Sir or Teacher Mike. Anything is fine. I really want you guys to be involved. And if you don't understand something, you can just, I've got the chat box open. You guys can just say, teacher, please explain that again, or teacher, can we stop a little bit there? Can you just go through that again? And we're going to try and see if we can get everybody. I think it was Vicky that said yesterday, on top of the mountain, so that nobody gets left behind and we all know exactly what to do and where we're going. Okay, so today I'm not going to give you guys homework. Yesterday I gave you guys a problem, but we're going to go through that problem step by step. Like I explained yesterday as well, for the remainder of this week, we're really just going to take some time and do the practical application of the things we did. So just examples, going through them, just making sure that everybody is up to date. I see Megan is asking a question. Where is she going to answer the questions? What we can do is, at the end of the lesson, I leave the screen up for a bit. You can screenshot or take a picture of the homework. But like I said, I won't be doing anything today, so you don't have to worry. And then you can see on the screen right now, there's my email address, which is mgeldenes81@gmail.com. And you guys can send it to me there. But as I explained yesterday as well, I really want you guys to take the opportunity and try. That is the most important thing I want from you guys, is to try. Yes, sometimes we don't get an answer correct, or we make mistakes. But you know what, as I always tell my students, is making mistakes is the best way to learn something. And the only way we will make a mistake or learn something is if we take the time to practice. And that is what I want us to do this week, is just to practice. Okay? So let's go and let's quickly look. Yesterday we went, okay, so this is just a peek at what we'll do today. Our objectives is to review tree diagrams and the homework, and then going through another question or two just as practical application. Okay. So again, I'm going to ask you guys quickly to type for me who can tell me what is probability? Maybe let's give the new guys a chance to answer first. So Vicky, Megan, you guys that were here yesterday, just don't type an answer just yet. Let's see if one of the new students can tell us what probability is. I'll give you a chance now, Megan. Let's just see one of the new students first, okay? I know you guys are eager to answer, so let's see. Anybody? Thank you, Vicky. Anybody, what is probability? There we go. The likelihood of something happening. Oh, wow, that's a very nice answer. Yes. So what is probability? Probability is the measure of how likely it is that something will happen. That's a very nice answer. Okay. It is also, we will look at this part of probability probably on Friday. It is the study of the chances of things happening in the future. Now, I'm sure maybe you guys have had a die that if you roll it, it just keeps coming up on a 2 or 3, or if you flip a coin, it just keeps coming up on head the whole time. So in that case, we're going to study the effect, and then from there, we will see the probability will change. Then it will not just be a standard, if it's a coin, a 1 on 2, a 50, an even chance, because then obviously there is something different of either the coin or the die, or something different in the application. Okay, so tree diagrams. Let's quickly go through that again. A tree diagram is used to express the possible outcomes of a single or a compound event. Okay, and then remember, each branch in the tree diagram represents a possible outcome. So I'm going to give you guys the example again quickly of a tree diagram. If we flip a coin, so here we've got the coin, we flip it. How many possible outcomes do we have? If we flip a coin, we either have a, there we go, Megan, that's quick, 2, either head or tail. There we go. So we've got 2 possible outcomes. Very nice, you guys. Okay, so there are the branches. And like we said, each branch represents a possible outcome. Okay, 2 possible outcomes. And then if we only have 2 possible outcomes, what would the probability be of it landing on a head or a tail? It would be a 1 in 2 chances. So like we explained yesterday, we can also express probability in 3 ways. There we go, 50%. We can express it as a decimal, which will then be 0.5. We can express it as a common fraction. There we go, Megan. A common fraction will then be 1/2. And remember, if we write it in a decimal, we divide the top number by the bottom number. And then, yes, as Megan says there, the third way we can express probability is a percentage. Way to go. Very nice. I like to see you guys encouraging each other as well. I love it. Okay. So now we're going to look at the tree diagram I did yesterday with you guys. I added in some more information on this one, just so that we can have a nice look at it. So now this diagram is going to be from the top to the bottom. So it's going to be the same thing. It's just not from left to right, but from top to bottom. And then this will be for if we flip a coin 3 times. Okay, so the first flip of the coin, we still have 2 possible outcomes, a head and a tail. Then if we flip the coin again, how many possible outcomes do we have then? Anybody? Three, 4. You guys, if you look at the picture, you guys will see that we have 4, 4, 4. There we go. Because remember, if we have, here we have head. Let me just change that quickly. And sorry, guys, I'm just quickly, because I want to show you, I practiced a little bit with my pen. So here we had one outcome, and here we had one outcome. So that's 2. Now on the next one, we have for head, we have another head. And for head, we have a tail. And then for tail, we have a head, and we have tail, tail. So yes, as you guys said, we've got 4 different outcomes. Okay, now if we flip the coin another time, a 3rd time, how many possible outcomes would there be? 8. There we go. Very nice. 8, 8, 8. 8 outcomes. Very nice, guys. So yes, we will have, if we go down the line, we'll say the first outcome would be head, head, head. The next one would be head, head, tail, head, tail, head, head, tail, tail. And then we will go down the other branch. We'll start with tail, head, head. And then we'll go down tail, head, tail, 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 head, and tail, tail, tail. Okay, so we will have 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. And there we have them. Does everybody understand where I got the HHH from? The HH is the first line this way, which is head, head, head. The second line is head, head, tail. And then just so down the line. The third one will be head, tail, head. Fourth one, head, tail, tail. There we go. Very nice. Okay. So head, 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 which will give us the head, head, head. Okay, now this we did, I gave this to you guys yesterday. And yesterday you guys like, oh, this is so difficult. But how many of you went and tried to do this question? I want you guys in the, I tried. Vicky said, I tried. There we go. Did you guys manage to do the question? Was it difficult? Was it easy? Vicky says it was hard, but I'm glad you guys tried, Vicky. You'll see if we go through it, we'll go through it step by step. Megan says it was okay. Yes. Okay. Okay, yes. If you guys weren't here, then yes, you wouldn't have had it. So that's okay. So let's read the question together. I said, draw a tree diagram of the following event and answer the following questions. Okay. So the local mall has a family day filled with fun activities and games. They have a spinning wheel with 3 colors, red, blue, and green, all equal in size. First of all, let me ask quickly, why is it important that they state it is equal in size? Why is it important that they state all colors are equal in size? Who can answer that question for me? There we go. Very nice. So we know, Megan said, so we know that it is all even. Yes. So that the probability of it landing on either red, blue, or green tells us that there's the same chance of either color coming up. If they weren't the same, then we would use different fractions to calculate the probability of colors coming up. Okay. Then the question says, there's a second wheel with the same colors. To win a prize, both wheels have to be on the same color. Okay, so then we only had 3 questions. How many possible outcomes are there? How many outcomes will win you a prize? what is the probability of winning a prize? So express the outcome as a fraction, a decimal, and a percentage. So yesterday I showed you guys, what the 3 ways we can express it. And remember, before we just give an answer, Vicky, here we have 3 possible outcomes, not just 2. So if you take 100 and you divide it by 2, then you would have a 50-50% chance. But if you divide it by 3, what would be the chances of one specific color coming up? Then you see, then there would be a difference, then it won't just be 50. But let's quickly look at it together then. Okay. So what do we do always, like I explained to you guys yesterday? We have to look carefully to see what do we know, okay? We always ask ourselves, don't worry, Vicky, it's okay. We're going to go through it. You guys will see the more we practice, the easier it will become. Don't worry about that. So what do we know? Okay, the local mall has a family day. Does that really tell us anything to use in the question? No, not really. They have a spinning wheel with 3 colors, red, blue, and green, all equal in size. There's a second wheel with the same colors. And then to win the prize, both wheels have to be on the same color. So the first thing we need is, the first important thing we notice is 3 colors, red, blue, and green, all equal in size, okay? Next thing we know is that there's a second wheel, okay? And they say the same colors, so identical to the first one. So also the wheel, red, blue, and green. Now, they also tell us, if you want to win the prize, you need to have both wheels on the same color. Okay. Here we go. There's our wheel. We've got a red, blue, and green. So if we spin the wheel, how many possible outcomes do we have? Who can tell me? How many possible outcomes? There we go. Cassie first. Vicky, there we go. So we have 3 possible outcomes. There we go. See? If we stick to what they ask us, go through step by step, it's actually very easy. We have 3 possible outcomes, red, blue, and green. Okay? So what do we know now? What do we need to do? We need to spin the wheel, or we need to spin the second wheel. Okay? Now, each second wheel would also give us the colors, what? Red, blue, and green. If we spin the first wheel and it gives us blue, then we also need red, blue, and green. And if we have green and we spin the wheel, we have red, blue, and green. And I can see Megan is already seeing what is happening over here. How many possible outcomes will we have? Megan already answered. Everybody with us? There we go. Sharon. We did. Okay. If you guys look on the screen, you will see where we got 9 possible outcomes from. If the wheel, let's just look at, I'm quickly changing the pointer here again to my pen. We've got the wheel. So, oh, there we go, Vicky's with us. So we had 1 spin that gave us red. And if we move on to the second wheel, we could also get red, blue, or green. If we had blue, we could get blue, red, blue, blue, or blue, green. And then the same with green, red, green, blue, green, green. Okay. So that is the tree diagram. That was the first thing you had to do is draw the tree diagram. And there it is. Okay. Vicky, don't worry, really, like I said, if we just go through this, if you look at the circle, you'll see there are 3 colors in a coin, 2 sides. Like we said, each arrow is a possible outcome. So this arrow over here will be the red, the blue, the green. So, and then the second wheel would have the same. Okay, so here we have that same wheel with the outcomes. The first question was, how many possible outcomes are there? And we counted them. We said 9 possible outcomes. Okay. Question. Okay, and then we had the next question. How many outcomes will win you a prize? First, let's quickly ask, who can remember what did the question ask? Or what did the little paragraph say? When will we win this prize? When will we win a prize? What needs to happen for us to win a prize? You guys are right, but listen to my question carefully. I want you guys to answer what needs to happen. There we go. If we get 2 of the same color. So how do we get the possible outcomes? Okay, so if we get how can we get the same color? If the first wheel spins a red and the second wheel spins red. Or if the first wheel spins blue and the second wheel spins blue. Or if the first wheel spins green and the second wheel spins green. So how many possible outcomes will win you the prize? There we go. So how many possible outcomes will win you the prize? We just answer 3. That is how many outcomes will give you a prize. Yay, winner! There we go. And then we've got the prize. Okay, third question. Third question was, what is the probability of winning a prize? Express the outcome as a fraction, a decimal, and a percentage. Okay, so now we know that there are 3 possible outcomes to give us a prize. So how do we express that in a fraction? Megan says 3/9. What do you other guys think? Also 3/9? There we go. And you guys remember, how do we get 3/9? It is the favorable outcomes, probability. The equation for probability we did yesterday is probability equals all favorable outcomes over the total number of outcomes. So we've got 3 that will give us the prize over a total of 9 outcomes. Okay. So C, as a fraction, we've got 3/9. But now remember, can we do something with 3/9 to make that fraction smaller? Because remember, 3 goes into 9. So how do we need to write that? Is that the final stage? If you guys look carefully on the screen, you'll actually see I gave the answer already. Remember, we're still in fractions. Tiro, we're still in fractions. We're not doing the decimal yet. So 3/9 can also be written as, look there where I circled, is to simplify. Yes, there we go, Megan. You need to simplify. And it gives us 1/3. Always check whether you can simplify a fraction. Sometimes there will be an extra point or 2 on your papers that you can just get for free if you just simplify your answers. Okay, now we also have to write it as a decimal. So who can quickly give me the answer for how would we write 1/3 as a decimal? Remember what we did yesterday, guys? Don't just write the numbers. Yeah, Sharon, you've got the right answer there. Remember, it is just a normal division. So you will take 1 divided by 3, 1 divided by 3, and then we will get 0.33. Okay, there we go. That's fine. Or if you can round it off, that's fine, 0.3. But normally try and use at least 2 spaces behind your decimal for your decimals. Okay. And then the last one, how would we write this in a percentage? What do we do to make a decimal percentage? We times it by 100. There we go. So we've got 0.33 as a decimal, and times by 100, we get 33.3%, like Megan said, 33%. There we go. Very nice. Okay, now, I actually saw a question from Vicky a bit earlier that I just want to go back on. Does everybody understand what we mean when I say you should simplify your answers? Like we had 3/9. Does everybody understand that? Vicky says no. Anybody else? Yes. Yes. Okay. Let me quickly just go one back. I'm just going to write on my screen here. So just for Vicky, Sharon, is it Luby? Okay. Remember, the answer here was 3/9. Let's quickly change here. We had the answer. Just wanted to change that to the whiteboard quickly. Mine is not changing now. That's fine. We will just do it on the screen here. So we had the answer 3/9. Okay. Can 3 go into 9? Can 3 go into 9? So if we count in threes, we've got 3, 6, 9. Okay, so 3 can go into 9. So normally if the number on top can go into the number in the bottom, then we can simplify the answer. So if we change 3 to 1 and we write it, how many times does 3 go into 9? It goes into it 3 times, and that's then why we will have the 1/3. Let's say we had 2/5. Can we simplify that answer? No, we cannot, because can 2 go into 5 without giving us a decimal? No, it can't. So let's quickly do another one. Let's put it over 3/15. 3/15. Can we simplify that answer? Okay, we've got one yes, we've got one no. We've got a yes and we've got a no. Okay, let's quickly. Yes, okay. Okay, guys, the answer is yes, we can. There we go. Megan said 3 goes into 15 5 times. If you guys are not sure, the best way to do it is just to take your calculator, type in 3 divided by 15. 3, or you take the bigger number and you divide it by the smaller one. So you will take 15 divided by 3 and you get 5. Okay, so yes. So 3, and how would we write that in a simplified form? 1/5. 1/5. Okay. Now, sometimes the top number doesn't go into the bottom number, but a different number does, okay? So, for example, if let's just make it an easy one. Let's make it 10 over 12. What number goes into 10 and in 12? That we can simplify that answer. There we go, 2. So what would be the simplified version of 10 over 12? There we go. Megan is fast. We will have 10 divided by 2 gives us 5. 12 divided by 2 gives us 6. Okay, so we'll move on to that. Just remember to check your, Vicky, you are right, but I think you just switched the numbers around. Remember, just to make sure the way you write it, that it's 5 over 6 and not 6 over 5, okay? Okay, let's look at the first question. Look at this. Now we've got a spinner, not just with 3 colors, but with 5 colors. Look at the 5-sided spinner shown in the diagram. When we spin the arrow, it has an equal chance of landing on each triangle. So here they tell us again that the colors are all the same size so that we know, and they actually even tell us it is an equal chance of landing on any triangle. Okay. Because they are all the same size. Now let's look at question number 1. List all the possible outcomes of getting an even number. Okay, here they're not even asking you anything about the color. They are asking you about the numbers in the colors. Okay, so we will just read through this and then we will go through the questions one by one on the next slide. List all the, but look at this in the meantime and see if you can pick up what the answers would be. List all the possible outcomes for getting an odd number. You guys remember what odds and evens are, right? Is there an equal chance of getting an odd number and an even number? Explain why, and then we'll go. So let's start. There we've got our spinner, 5 triangles, 5 colors, 5 numbers. The first question was, list all the possible outcomes for getting an even number. So how many chances do we have? Yes, Vicky, you've got it. Chances of it. But remember, now here is where I want you guys to look carefully. They didn't ask what was the probability. Jay, look at this first word. It says list. List all the possible outcomes. Okay, so if we list them, what are our even numbers? 2 and 4. Okay, so I explained you guys have to be careful and read your questions very nicely. Okay, so they just say list them. So we'll have 2 evens, number 2 and number 4. Okay, question B says list all the possible outcomes for getting an odd number. So there we go. Megan is fast on this one now. Okay, so yes, all the possible outcomes for getting an odd number, it's 1, 3, and 5. Question C, part C. Is there an equal chance of getting an odd number and an even number? Explain. Is there an even chance? No. There are more, there we go, very nice, Megan. There are more odd numbers than even numbers, okay? I'm glad you're with us, Vicky. Can everybody else hear nicely, or is it just Tiro that has some problems with the sound?
Teacher, sound
Yes.
is fine on my side.
Is it still fine? Okay, I'm great to hear that. Megan says there's also some breaking up. Okay, I'm going to speak a little slower just to make sure that everybody can hear nicely. So yes, like you guys said, there isn't an equal chance because there are more uneven numbers than even numbers. And then part D of the question, how could you use this spinner to design an unfair game? Okay, like you guys said, it is you can only win a prize if you spin an even number. Okay, so because there's only 2, so you're less likely to win. Okay, it would be unfair if you win only if they get an even number. Okay. Now, here's the fun part. Draw the tree diagram with the first set of branches showing the possible outcomes of spinning the spinner in question 1. Then add the outcomes of a coin toss to each of the branches. Okay? Okay, so if we spin the spinner, how many possible answers do we get? We get 5. 1, 2, 3, 4, 5, the 5 colors of the spinner. Okay, now we can also, if we flip a coin, how many sides are there to a coin? 2 sides to a coin. So if we spin the spinner and it's on 1 and we flip a coin, it can have either a head or a tail. Can everybody see? Everybody understand? If we spin a 2, we can either have a head or a tail. The same with all the numbers all the way to the end. So 3, we can have a head or a tail. 4, we can have a head or a tail. 5, we can have a head or a tail. Okay? So how many possible outcomes do we have on this tree diagram? We can just count them from the top. 10. There we go. Sharon, very nice. We can just count them from the top. We have 10 outcomes. Okay? That first outcome, what would the first outcome be? The first outcome would be a 1 and an H. There we go, Megan. The first outcome, a 1H. Second outcome would be then a 1. Whoops. Sorry, guys. I pressed end on my screen instead of next. It would be a 1 tail. And then we just go the same way all the way down. The third one would be a 2H. Next one would be a 2T. The next one would be a 3H. There we go. Megan is even going faster than what I'm going right now. So yes, we just go down the list, listing all the possible outcomes of our tree diagram. 3 head, 3 tail, 4 head, 4 tail, 5 head, 5 tail. That's easy, right? Are you guys with me so far? That's easy, yes? There we go, yes. We just, basically all we do is we just list what each item can possibly be. So the spinner either had a 1, 2, 3, or a 5. So we just list them. The coin had a head or a tail, and we just list them with every outcome from the spinner. Okay? Now, part B, it is how many possible outcomes are there altogether? I think I made a mistake over here. And yes, don't look at my answer there. I had a typo, but we counted. There are 10 different, 10 different outcomes. You see, even your teachers make mistakes sometimes. We sit and we try to prepare these things for you guys, and then I make a silly mistake like that. 10 possible outcomes. Okay. How many outcomes are there for getting 4H? Remember 4, then we just look down the line. There's 4, 4H. How many possible outcomes are there? Only 1. Okay. Now here, remember, if they ask you how many, you just write the number. If they ask you what is the probability, then you will write it as a fraction or a decimal or percentage. It is 1 over 10. Okay, how many outcomes are there for getting an even number and heads? So now we have to first look, you know what? Where are our even numbers? Everybody give me the even numbers quickly. They are, we're going to do that. If we want to write that in a decimal, Megan, you just remember, because it's only 1. So you just go 1 divided by 10, which is be then 0.1. Okay, there we go. Megan said our even numbers are 2 and 4. Okay, now from 2 and 4, how many heads do we have? 2 and 4 head, 4 head. So we can have 2 possible outcomes. Okay, because the question asked, how many outcomes are there for us getting an even number and a head? So looking at this, the even numbers are 2 and 4. We can only have 1 head. So only two possible outcomes, 2H and 4H. Then what is the probability of getting an even number? Because we have, here's the question again, what is the probability? Then we cannot just list or say the number. We have to remember our equation. Probability is the number of successful outcomes over the total of possible outcomes. So we know we've got 10 outcomes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we know we only have 2 outcomes that will give us a head and an even number. So we write 2 over 10. And then here again, we can simplify. 2 over 10 gives us 1 over 5. 2 divided by 10, 1 over 5. Okay. Does everybody understand? Yes, Megan is with us. I want to see you guys. Are you guys with me? Is it Luby? Do you want to ask a question? No, okay, it's fine. Just wanted to say yes, we understand. Okay, guys. I really hope that that would help you guys. But if tomorrow we're going to look at the two-way tables again. Okay, remember, two-way tables are only when we have 2 events happening at the same time. But like we went through the tree diagram today, we'll take time and go through two-way tables as well. Okay. Then remember, this week that's all that we have to focus on. So if there's any questions you guys have, you know, I'm going to put my email up again. Take it down, take a screenshot, and let me just see if I can just go to slide. Take my email address. If there are any questions, don't hesitate to email me, and then, you know, say, teacher, I don't really understand this. If I think that, you know what, maybe everybody else might not benefit from it, then you know what, I can try and help you on email. But if not, if I think, you know what, more people would benefit from your question, then we do that. And we will go through it again. So this thing is giving me some. There we go. There's my email address again. Take a screenshot, take a picture, and then we can always address specific questions that you guys might have. So tomorrow we're going to focus on two-way tables. But I really want to thank you guys for joining me again today. And I hope to see all of you. I'm glad we had some new students today. I hope to see all of you again tomorrow. I know that Megan said she won't be here, but I really appreciate it, and thank you guys for participating. And you'll hear me say this a lot. You'll probably get tired of me saying this. You know what? Practice makes perfect. So the more we practice, the better we get, the more comfortable we get. So I'm really glad to be able to teach you guys. Well done. Keep trying. And then I'll see you guys tomorrow. Thank you very much, guys. Have a lovely day. Bye-bye.